Today we're on page 5 of our Chapter 11 notes packet, section 11.3. Basic graphs of sine and cosine functions. The graph of each trig function, sine and cosine, is an endless repetition of a basic curve, so it goes on forever. So the functions are called periodic functions, otherwise known as sinusoidal graphs. A single basic curve is called a cycle. So this is important to remember. A single basic curve is called a cycle. There are 5 important points in each cycle, all evenly spaced along the x-axis. So what we have here, we have a small sketch of y equals sine x of one complete cycle, or one single basic curve of our sine graph. This is going from, this here is our y-axis, -1, 0, 1, and this is our x-axis. And we are going from 0 radians to 2 pi radians. So we have here one complete, or one single basic curve of our graph y equals sine x. So this is one cycle of y equals sine x. Now if you notice, we start at 0 radians, we are at 0 on the y-axis. At 2 pi radians, we're back on y equals 0. And midway between, we're back on the x-axis, which the equation of the x-axis, remember, is y equals 0. And midway between our two values, from 0 radians and pi radians, we're up at 1 on the y-axis. So we have here our 5 important points. They go 0, max, 0, min, 0. So again, sine curve is going to start at 0, one complete cycle going to end at 0, midway between hit 0, and all from the x values from 0 to 2 pi. The sine curve is symmetric with the origin, meaning it has 180-degree rotational symmetry. So if we were to rotate this paper, turn it upside down, okay, we have the same sine curve representation as when we started at it, looking at it right side up. Y equals cosine x. Again, this is our y-axis. This is our x-axis. Y equals cosine x starts at 1. At 2 pi radians, we'll be back at a height of 1. And midway between is down at -1. Between 0 or 1 and -1, it crosses the x-axis, so it has a y value of 0. And between -1 and 0, it crosses the x-axis, having a y value of 0. So for our cosine curve, cosine starts at 1. At 2 pi ends at 1. Midway between is at -1. So cosine starts at the max, 0, min, 0, max. And the cosine curve is symmetric with the y-axis. The amplitude and period of basic curves are changed by constant factors in the equations. So we have y equals a sine bx. The a value, or absolute value of a, is going to be the amplitude. And the period is affected by the b value. But there's a formula for period. But these are amplitude we're already familiar with, but period is another vocabulary word we'll have to know. So a constant multiplier of the function, the a value, affects the amplitude. A constant multiplier of the angle, the b value, affects the period. The amplitude of the function is half the difference of the y max and the y min values, how high the graph gets. So amplitude can be gotten by taking the absolute value of a, or if I look at the cosine curve above, it'd be the y max minus the y min divided by 2. The y max here was 1, the min was -1, so 1 subtract -1 is 2, and 2 divided by 2 is 1. So the amplitude here was 1, as it should be, because what's our coefficient of cosine here? The a value would simply be 1. The period of the function is the horizontal length needed for one full cycle. And here is the formula. It's equivalent to the absolute value of 2 pi divided by our b value. And next, the frequency is a number of cycles or whole curves from 0 to 2 pi. So in interval length from 0 to 2 pi, the b value represents the frequency. So these are 3 vocabulary words we need to know: amplitude, period, and frequency. Now let's look at them on the next page. We have for each equation, state the amplitude, which is the absolute value of a, the period, which is 2 pi over b. Now remember, period is the length of one cycle. And the frequency. Now, what does the frequency, the absolute value of b, tell you? That tells you the number of full cycles from 0 to 2 pi. Okay, so for y equals 2 sine x, right? And these are of this form: y equals a sine bx, or y equals a cosine bx. So a, or the amplitude, and which is the coefficient of our sine or cosine. So let's just go right down, okay, pull out the a values. So number 1, our a value is 2, so the absolute value of a is 2. Or your amplitude is always going to be positive. It's negative, never going to be negative. Number 2, the absolute value of -3 is 3. Number 3, what's in front of sine here? If there's nothing there, there's the 1. Coefficient of sine here is 1. Absolute value of 1 is 1. A value here is -1, but the absolute value of -1 is 1. And number 5, the absolute value of -1 is 1. 6, a value is -1, its absolute value is 1. And 7, our a value is 2, absolute value of 2 is 2. So amplitude is always going to be positive. Next, we're going to fill in the frequency, which is the absolute value of b. And b is the coefficient of your x, the number in front of x. So in number 1, the coefficient of x here is 1. So our frequency is 1. Number 2, the coefficient of x is 1. Number 3, our b value is 2. Number 4, our b value is 1/2. 5, now we have x divided by 2, so this is 1 divided by 2. So it's the same as 1/2 x. So these two are the same, just a different way of writing them. 1/2 x, or x divided by 2. Number 6, our b value is 3. And number 7, This would be 1x divided by 3, or a b value of 1/3. Okay, so now that we have the b value, now we'll use the formula to find the period. So using 2 pi divided by b. All right, so the period for number 1, y equals 2 sine x, would be 2 pi divided by 1, which is 2 pi. Our period for number 2, 2 pi divided by our b value, 2 pi divided by 1 is 2 pi. Number 3, 2 pi divided by 2 is pi. And number 4, 2 pi divided by our b value of 1/2. 2 pi divided by 1/2. Dividing by 1/2 is the same as multiplying by the reciprocal. So if we multiply by 2, 2 pi multiplied by 2 is equal to 4 pi. Okay, now before I continue completing the period for cosine for 5, 6, and 7, let's look at sketching graphs for numbers 1 through 4. All right, we have y equals 2 sine x. The period of 2 pi tells me that I need a length of 2 pi for one complete cycle. The frequency is 2, the amplitude is 2, so that tells me how high my sine curve is going to get. All right, so for one complete cycle, I need to go from 0 to 2 pi radians. And my sine curve, remember, sine starts at 0, ends at 0, midway between is 0, and midway between 0 and this would be pi radians is up at 1. But in this case, the amplitude is 2, so it gets as high as 2. And between pi and 2 pi, it goes to the minimum of -2. So I have my x scale marked. Now for the y scale, this point here would be 2, and this one down here, -2. And checking the frequency tells us that we have one complete sine curve in the interval from 0 to 2 pi, right? The number of full cycles or full complete curves from 0 to 2 pi. So there we have one. Number 2, we have y equals -3 sine x is what we want to graph. The period is 2 pi, so for one complete cycle, we go from 0 to 2 pi, and that will get us one complete cycle of our sine curve. Now, it starts at 0, ends at 0, midway between is at 0. But now our a value was -3. So instead of between 0 and pi being at +1, it's going to be inverted, right? It's going to go down to the minimum, to -3. And between pi and 2 pi, it'll be up at +3. So my y scale here, labeling this, would be -3, and here +3. And there we have a sketch of the graph y equals -3 sine x. Next, we want to graph y equals sine 2x. Okay, well, for one complete cycle, we need a length of pi. I really like the frequency for these because it's telling us that from 0 to 2 pi, right, and I am going to go from 0 to 2 pi, it's telling me I would have two complete sine curves. All right. If I'm looking to graph just one period, one complete cycle, then from 0 to pi, I should have one complete sine curve. From 0 to pi, right? Our period is pi. So from 0 to pi, one complete sine curve. So starts at 0, at pi would end at 0, midway between be at 0. So we have 0, then our max, all right, our a value was 1. So 0, max, 0, min, 0. Here we have one complete sine curve from 0 to pi. Now again, the frequency tells us how many complete full curves we have from 0 to 2 pi. So if I want to just check on the calculator, and by key in y equals sine 2x, look at the graph, make sure we're in radians. Okay. So from 0 to 2 pi, I have 1, 2 complete sine curves. One complete sine curve is from 0 to pi, and that's what we sketched here, right? But let me just continue, and I'm just going to draw this kind of dotted. So from pi to 2 pi, we'll get a second complete sine curve. So 0, max, 0, min, 0. Next, y equals negative sine 1/2 x. So for one complete curve, we need an interval length of 4 pi. So let me go out from 0 to 4 pi. That means let me mark halfway would be 2 pi, and half of 2 pi would be pi, and between 2 pi and 4 pi would be 3 pi. All right, so for one complete circle requires a length of 4 pi. So it's going to start at 0, this is a sine curve, at 4 pi end at 0, midway between at 2 pi be at 0. And our lead coefficient was negative, a -1. So instead of going from between 0 and 2 pi, going up to -1, or sorry, going up to +1, we start off by going down to the minimum -1. And then at 3 pi, we'll be at +1. So let me just label this 1 and this -1. So there we have one cycle of our sine curve. Now, the frequency is telling us that we would have half our sine curve from 0 to 2 pi, right? This would be, this says half a complete sine curve, half curve, from 0 to 2 pi, right? From 0 to 2 pi, yep, that's all we have, is half of a complete sine curve. All right, our next equations are cosine equations. Let me go back to and fill in the frequency here. I'm sorry, we have the frequency of half, fill in the period. So the period is going to be 2 pi divided by a half, which is equivalent to 4 pi. Now remember, we've switched the cosine curves. So for one complete cosine curve, I need an interval length of 4 pi. So from 0 to 4 pi will get me one complete cosine curve. And cosine starts at the max, ends at the max. But be careful, okay? We've got that leading negative, so that means it's going to be inverted. It's actually going to start at its min, end at its min, so at 4 pi would be at -1. Midway between at 2 pi would be at +1. And between -1 and +1 here, it would cross the x-axis. And between 2 pi and 4 pi, midway between, would cross the x. So there we have one complete cycle of our y equals negative cosine a half x. And this is telling me the frequency is a half. That's telling me from 0 to 2 pi, we only have 1/2 of a sine curve, or excuse me, a cosine curve. Next, y equals 3 negative cosine 3x. I'll use the b value of 3 to complete the period. It's 2 pi divided by 3. That's so 2 pi over 3. So I have to go out 2/3 pi. All right. If I'm using the frequency, it's telling me that I would have from 0 to 2 pi, I would have 3 complete cosine curves. So I would have 3 complete cosine curves. From 0 to 2 pi. So I actually am going to go out to 2 pi. All right. Now, for one complete curve, it would be 2/3, right? 2/3 plus another 2/3 plus another 2/3. Here we go with our fractions. That would be 6/3, which is 2 pi. So I'm going to try to break this up into, trisect this. This looks about right, I hope. So this would be 2/3 pi, and this would be 4/3 pi, and this would be 6/3 pi, right? And 6/3 is equivalent to 2 pi. Okay, so from 0 to 2/3 pi, I should have one complete cosine curve, all right? So cosine, and again, this one had a leading coefficient of negative, so instead of starting at 1, I'd start down at -1. And at 2/3 pi, I would be back at -1. Midway between, up at +1. And then between -1 and +1, be on the x-axis, and between 1 and -1 be on the x. So here is one complete cycle, right? It's one complete cosine curve. And now if I continue, I should draw 2 more, because I should have 3 from 0 to 2 pi. And again, I'm going to sketch these dotted. Okay, so there and there, midway between, be up at +1. Marking my 5 points always first, and then connecting them. If I check using the calculator, take your calculator, all right, and let's key in y equals negative cosine (3x). Negative cosine 3x. Okay, there we have it. Okay, it's inverted because the leading coefficient was negative, so we started at -1. Here's one complete cycle, second complete cycle, and then the third. So we have 3 complete cosine cycles. from 0 to 2 pi. All right, and finally y equals 2 cosine of 1/3 x. Here our b value is 1/3, so our period is 2 pi divided by 1/3. Dividing by 1/3 is the same as multiplying by 3, so if I take 2 pi and multiply by 3, I get 6 pi. All right, so we'll need a length of 6 pi for one complete cosine curve. So this is going out to 6 pi. This is for one complete cosine. And a value was 2, so instead of starting at 0, 1, we start at 0, 2. At 6 pi, we'll be at 2. Midway between, at 3 pi, we would be at -2. So let's put 2, -2. And then midway between on the x-axis, on the x-axis. Now the frequency, the 1/3, is telling me that from 0 to 2 pi, which would be about right here, I would have 1/3 of the cosine curve. So let's just check that on the calculator. Let's look at this. Y equals 2 cosine of 1 divided by 3x. From 0 to 2 pi, yep, we have like a little more than a quarter. We've got 1/3 of our cosine curve. Okay, so a final transformation will allow us to horizontally stretch and compress sinusoidal graphs. So horizontal stretch or a compression this is what we did. We stretched and shrunk them. A compression is also a shrinking or a shrunk. It's important to be able to do this because in real world modeling, most periodic functions do not have a period of 2 pi. So let's look at one last illustration here. On the grid below is the graph of the function y equals 3 cosine x. Using your calculator, sketch the graph of y equals 3 cosine 2x on the same axis. Okay, again, I like to do this without the calculator when possible. This is telling us that, all right, this is our amp. Our A value is 3, so our amplitude is 3. Our period, the B value is 2, so our period is 2 pi divided by 2, which is pi. And our frequency is 2. All right, so that's telling us, I really like the frequency because when we're working from 0 to 2 pi, that's telling us we're going to have 2 complete cosine curves. Okay, so we need 2 complete cosine curves here. So what is the length of one complete curve? It's a length of pi. All right, so let's take our pen and, all right, we're starting at 3. At pi, we'll end at 3, and midway between be down at the minimum of 3. Now, midway between 3 and -3 we'll cross the x-axis, and midway between -3 and +3 we'll cross the x-axis. So here's one complete curve. And now we need the second one from pi to 2 pi. All right, start and midway, and then midway between each pair, crossing the x-axis. And now it's symmetric with the y-axis, so we can just reflect these over the y-axis to get our points and get the other portion of our graph from 0 to negative 2 pi. All right, so the blue here is y equals 3 cosine 2x, and you can check it with the calculator. How many full cycles or periods of this function now fit within 2 pi radians? Well, that was our frequency. That was 2. And using your calculator, sketch the graph of y equals 3 cosine a half x on the same axes. All right, so I'm going to use red for this. A half x, that means our b value is a half. So our period would be 2 pi divided by a half, which is equivalent to 4 pi. And our frequency is a half. So we would get only half a cosine curve from 0 to 2 pi. All right, we'd only get half a cosine curve from 0 to 2 pi. So if I'm looking at a full, if I'm looking at a full cosine curve, all right, we would only get half of it, this portion. Okay, so we'll start off at 0, 3, and then at 2 pi, we should be down at our minimum, negative 3. And then halfway between those two values, we'll hit the x-axis. And there we have half our cosine curve from 0 to 2 pi. And it's symmetric with the y-axis. And here's our other half. And again, we can check it with the calculator, but over 30 minutes, I'm sorry. Thank you very much.